As an exercise, let's come up with a wiring diagram for this 2 horsepower, 3-phase, 120-volt motor whose operation and control is represented by this ladder diagram. We can see in the ladder diagram that the stop push button is connected to L1. This is, of course, a control voltage. In the wiring diagram, we would bring one side of the stop push button to the L1 connection in the starter. Note that the connection is made to the small circle terminal to denote a control circuit connection. The other side of the stop is connected to one side of the start push button. This side is also connected to the number 2 terminal, which corresponds to the auxiliary set of contacts in the starter. These contacts are labeled M in the ladder diagram, and as can be seen, the numbers 2 and 3 of the starter connections are also included. This side of the start push button will be wired to the number 3 terminal of the auxiliary contacts. From the ladder diagram, we can see that this connection is also wired to the starter coil. The other side of the coil goes to one side of the overloads, and from the other side of the overloads, we connect to L2 to complete the circuit. These 2 wire connections, as we mentioned earlier, could already be wired in the starter when it was shipped from the manufacturer. Regardless, it must be shown in the wiring diagram. If we added a pilot light like this in the ladder diagram to indicate a motor on condition, we would include it in the wiring diagram coming from either this point in the push button or this point at the terminal number 3 connection. Let's connect here, since we only have one wire connected to the push button, and we have 2 at terminal 3. The other side of the pilot light will be wired to L2 in the starter, closing the circuit just as represented in the ladder diagram. Every time the start push button is pressed, the motor will start and the pilot light will be lit. We can see that it is easier or more convenient to follow the sequence of operation of a control circuit in the ladder diagram rather than in the wiring diagram. However, if you are troubleshooting the circuit and the motor load, it is better seen in the wiring diagram, which described precisely where you would have to look in the starter for the components to test. Both circuit diagrams are useful when troubleshooting. If this motor had been a high voltage motor of, let's say, 480 volts, then we would have used a control transformer for the power to the control circuit, and the connections would have to be made like this in the wiring diagram. The power would now be reduced from 480 volts to 120 volts. This transformer will most likely also be located in the same enclosure where the starter is housed. Note that we have also added overcurrent protection for the control circuit using a fuse. This fuse could have been placed in other locations using other methods, depending on the local, state, or NEC rules.